Well, can you believe it? This is the last lesson of the year. That great big boulder represents your accomplishments. That hill that it had to be pushed up represents all the obstacles you've overcome. And the cow is there because, well, cows are just really cool and trendy. So we want to identify if a sequence is arithmetic, geometric, or neither. So let's maybe do an example of each and then see what else fun we might do on this assignment. Okay, so what's going on here? Well, I know 5 plus 2 is 7. I know 7 plus 2 is 9. 9 plus 2 is 11. Sure enough, it looks like we added 2 every single time. Since I added 2 every single time, it's arithmetic, and I can just circle the A, right? And sometimes it's easy enough, you can just eyeball and say, hey, look, I added 2 every time. I'm just going to circle the letter A. Ooh, another example. Is it arithmetic? Is it geometric? Is it neither? Well, let's see. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. Hey, look, we're multiplying by 2 every single time. Since we keep multiplying by the exact same number every single time, we say, oh, it's a geometric sequence, right? So I would just circle the G for geometric. What the next example is going to be, because we had one arithmetic, we had one geometric. I wonder what this one's going to be. Let me see. Well, maybe we added 3 every time. 3 plus 3 is 6. 6 plus 3 is 9. Oops, no, I don't see a 9. Maybe I kept multiplying by 2 because I'm obviously not adding 3. 3 times 2 is 6. 6 times 2 is 12. No, I don't see a 12 in that list, so I'm not multiplying by 2 every time. So this is just some weirdo pattern, right? It's not arithmetic. It's not geometric. So this is what we call neither. Right? It is neither arithmetic nor geometric. So I can circle the N for neither. The other thing I want to have you do today is write the first 5 terms of each sequence. So let's do a few examples. Let's pretend the nth term is 4n plus 1. You might recognize this as being arithmetic because this one goes by 4 every time. Okay, so what's the first term? Well, I have to do 4 times 1 plus 1. I get 5. What's the second term? 4 times 2 plus 1 gets me 9. And I should say, oh yeah, it's going to keep going up by 4. So I'm going to speed things up here. Right? 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 4 is 17. 17 plus 4 is 21. There's the first 5 terms. And if I look at this next example, you might say, ooh, that crazy exponent of n minus 1, that's going to be geometric. Now again, let's plug in the number 1 and see what happens. Okay, so 1 minus 1 gets me 0. 3 to the 0 power is just 1. 2 times 1 is 2. Oh, duh. Come on, it's geometric. I should have just looked right there and said, hey, the first term in the sequence has to be 2. Right? That's what that 2 is telling us. And then the 3 says, to get the next one, multiply by 3. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. Those are the first 5 terms. Okay, let's do one more example. And you're like, wow, it doesn't look like arithmetic, right? Because arithmetic kind of looks like y equals mx plus b. And it's not geometric because I don't have that n minus 1 exponent. So this is a neither. And the neithers are the one where there's really not much of a shortcut. Right? Arithmetic, I can say, hey, look, we went up by 4 every time. Geometric, hey, I multiplied by 3 every time. Neither, oh no, I got to plug them all in. Okay, so 1 factorial over 12. Well, 1 factorial is 1. 1/12 won't simplify, so that's the first number in the list. Okay, the second number, 2 factorial over 12. So 2 factorial is 2 times 1, which is 2. 2 over 12 will reduce and become 1/6. That's the second number in the list. Let's find the third number. 3 factorial will be 3 times 2 times 1. 3 times 2 times 1 makes 6. 6 over 12 reduces to 1/2. I don't see an obvious pattern, so I gotta keep going. Fourth number in the list, 4 factorial over 12. Of course, 4 factorial is 4 times 3 times 2 times 1. That makes 24. 24 divided by 12 is 2. Interesting, it's not even a fraction anymore. Let's find the fifth number in the list, also known as the fifth term in the sequence, if we want to speak like a mathematician instead of a normal person. 5 times 4 times 3 times 2 times 1. Might want to grab a calculator for that puppy. That's going to be 120. 120 divided by 12, well, that's going to be 10, right? Because 12 times 10 is 120, so 10. So here's a rather weird list or sequence, right? If I'm a mathematician, I'll call it a sequence. If I'm a normal person, I'll call it a list. But look at that, 1/12, 1/6, 1/2, 2, 10. Bizarre looking list, but that's what happens with those neithers. I look up in the sky, I see some puffy white clouds, and they spell out worksheet. And this is the last one of the school year. And so after the school year is over, perhaps my brain will go on vacation, look at those palm trees, that sandy beach, that shallow water, and all those cows just hanging out. Oh man, that looks like paradise.